Hey guys, ScannerDanner here. I want to first wish everyone a happy new year. It's 2020. This is my first video for 2020, and I just want to thank my community for being with me for so long. I believe my first video was late 2011, maybe October or November of 2011. So it's been a long time. Some of you have been with me, and I just wanted to thank you for that. When you get to this page, one of the things I have you guys do, because I get this question a lot, is, where do I start? And so make sure you're watching this navigation and where to start video right here. The playlist that you're looking at would be all of my chapter lessons in my book, as well as exclusive case studies that are in here. Let me take you to chapter 2 first, and let me show you the playlist here. Chapter 2, switch inputs. And you see the lectures that I have, the page for page stuff, and then I have expanded content material here too. And so maybe I want to know what's in this chapter, and so I have to click on a lesson. Say, let's pick the third one in pages 16 to 23. Notice it takes me to another page that everything is all opened up now. And what's nice about this page is I can scan quickly on what topics are covered. So I look at the list that's there, and I can go up and down the page. This will be the previous lecture. This will be the first one in the list, and I've added related videos too. So as I'm talking about these particular subjects in this lecture, and it plays from right here, I would have done a video that would have helped guide you in using those testing methods, and so those would be over here as well. Now I'm going to take you to the video that I want to show you. It's in my chapter 21 playlist. The one I'm going to be showing you guys is this case study review of a Ford variable reluctance crank sensor. And that's where you'll find this as a premium member. This is now going to be here on YouTube as well. Give you guys a freebie. That's the stuff I'm doing behind the scenes. It's been a great year. I'm looking forward to 2020. And I just want to thank you guys again for being here. And here is a premium video that you guys can learn from. And come over and check out my channel, guys, please. You can't beat what I'm offering. It comes out to like 37 cents a day or something like that. For the amount of information that's here and the education I'm offering, you can't find it anywhere for that. So thanks again. I look forward to hearing your comments. Enjoy the video. This morning's topic is actually a case study I did last night, and as I was saying, it is David's fault on why we're doing it this way. He wanted to be there with me, and actually a few of you expressed interest in coming, and if you ever want to do that, that would be fine. So this morning, what I thought I'd do is show you guys this case study I did yesterday and film this part live, so that way if you have any questions, that we can have those questions and everybody can benefit from it. The nice thing about this is we just covered variable reluctance sensors yesterday, and we were going to today get into the testing part of it, and that's exactly what I did on this vehicle yesterday. So it's a perfect lead into where we're going for the rest of the day. So let me just play this. It's not real long, it's 15 minutes. You guys stop me whenever you have a question, and we'll try to get that on here too. And first thing I'm doing is just a quick no spark test. Do you need to get your phone, Jimmy? You want to grab it? No? Okay. So I'm just using a low-tech, method that I could get electrocuted doing, but don't care. And I'm just holding the air gap here next to the spark plug that's removed. And go ahead and crank it, Jimmy. Okay, good. All right, as you can see, no spark. Next low-tech tip is to watch our service engine soon light or check engine light. And this is for Fords only. I cannot promise you that this works on other vehicles, but we want to crank it while we're watching that light. On Fords, if the computer is receiving a crank signal, it will turn that light off during cranking. So the check engine light will actually turn off during cranking when the computer receives a crank signal. Next quick test is to watch the tach. Let's back up on that last statement for a second. It's a really good tip that works on Fords, but I can't promise you it works on other vehicles.
How new Fords?
Any Ford that I've ever worked on. I'm not sure. Actually, the question better would be how far back does it go? I'm not sure, but it's a test that works.
I've used it over the years. It's really, I'm kind of throwing out feelers, if that makes sense, in direction and where I'm going. First is no spark, and next is, well, do I have an input problem, or do I have a computer problem or output problem? That's kind of what I'm thinking about. And so the next easiest steps are, things like that. If I can look at a check engine light, crank an engine over, and the light goes out during cranking, again, this is a Ford thing, then that tells me that the crank signal's there and I may have gone in a different direction.
Is that still true?
Yes. Well, I can't say that for sure in a 2015 Ford. Any of you driving a newer Ford, we can check later today. I think what I get a lot is you guys want me to give you absolutes, which I understand that. We were talking about that this morning, absolutes, and I can't do that. The only thing I can give you is tips and guidelines. So this check engine light idea is a guide. We don't trust it completely. If you think you have a crank sensor signal, you might want to still confirm it with another test, or vice versa. If you don't think you have a crank sensor signal, then confirm it with another test. Just use all of these together to get you through the process quicker. That's all we're doing. Okay? So the check engine light should go out again on a Ford when we're cranking if the computer's receiving a crank signal. If I would have seen that in this video, I would have gone in a different direction. I would have probably started checking powers to the coil next and make sure it was there, because I don't have spark. And then the other thing that I'm thinking about as we're doing this, we just went over circuit designs, if you remember. And our circuit designs on this vehicle would be crank sensor to PCM, PCM to coil. So it'd be this. See if this rings a bell. I would have my crank sensor signal goes to my PCM. My PCM is going to, let's see, on this car, I didn't even pay attention. Is the coils directly controlled? Yeah, but on this one, I don't think there's an ignition control module. I believe the coils are directly controlled by the PCM. We can double check that later, but these are the things I'm thinking about as I'm going through this. What components are in between? Okay? I know it's not an older bypass system, which would be crank to ICM, ICM to PCM, PCM to ICM, and ICM to coil. I know for sure that it's not this design. So these are things I'm thinking about. These are some topics we talked about the other day. Okay? I'm looking for speed.
This is like the Dodge we had. Where
Yes. This is like the Dodge pickup that has computer controlled coil, no module in between. The computer controls it. I'm pretty sure this Ford is like that. The only difference with this one though, Nick, is I can't tell this computer to fire this coil. Ford doesn't let you do that. Go figure. If it was a Chrysler, I could. Ford, nah, not gonna happen. Okay, so the next one I'm doing now is I'm looking for a tachometer bounce, and again, what would that tell us? If I had a tach that bounced during cranking, crank signal is there. It's just a guide. I'm just using this stuff as a guide.
Cranking it. Tach does not move, so the next direction we're going is toward the crank sensor. We'll get trouble codes, if there are any, on the scan tool next.
Boo.
Trouble codes aren't going to help us on this one.
What is P1000 on a Ford? It is manufacturer specific. We only see these on Fords, the P1000 codes. I haven't seen those on any other vehicles. But P1000 is, someone was in here and cleared the fault codes. That's what that means. OBD system checks incomplete. That means all of your readiness monitors, they haven't completed yet. There could be fault codes in this car I have no idea about. I'm not worried about the fault codes. This car is in for a no start situation. That's what I'm doing, but I have no help here at all. Someone was here, cleared the fault codes, not sure why.
Was here already before us. There was some work done on this vehicle, had new plugs and new coil and some other work done. Symptoms were he was driving it, it lost power, and I guess he decided to do a tune-up. I'm really not sure everything that was done, but as you can see, trouble codes are not going to help us. Next test is RPM on the scan tool during a crank.
And that one really wasn't necessary. It's really just another way to do it. If you don't have a tachometer, it would be the same thing as my tach test that I just showed you. Look at the tach, see if you have an RPM fluctuation on the tachometer. If there's no tach, then this is another method. We pull up scan data, look at RPM on the scan tool. Would it have been to my benefit to customize this data list in this particular case?
Yeah.
Yes. Why would I want to customize this and just look at the RPM?
Just that way you don't have any interference or anything.
Or lag and waiting for this thing to update, right? So it would have been a good idea. I didn't feel it necessary, as direction dictates we have an issue with our crank sensor already. And I'm going to mention something here about this -40 number in a second.
You can see no RPM on the scan tool either. I am now looking for cam and crank data PIDs. And you guys need to ignore this IAT sensor that's reading -40. I have the mass airflow unplugged. We are in the process of removing some components so we can get to the crank sensor and test it directly. Just want to make sure that we don't have any other data PIDs we can use. So there are no cam and crank data PIDs on this vehicle anywhere. I checked every single data list. None of these are going to help me.
All right, so depending on the vehicle we're working on, we can have a cam and crank data PID that would help us. If you guys think about the Dodge truck, Nick and Dave, and who else was on the Dodge truck, and Matt, if you remember, we had a cam and crank data PID on that truck that we were looking at. And I think it'd say camshaft counts or crankshaft counts. You guys remember that? And then it gave us a number. And then there's another version that Chrysler uses that would say cam crank. Hard to see that. Red's better. Is red better? Cam crank, and then the data PID would actually say yes or no. And then what I would look for in this case is when I crank the engine over, I want to make sure that these guys say yes the whole time. If I see one that says no, then I have good direction. If I see one that's saying yes, no, dropping back and forth, that gives me direction as well. There's things that we can run into on Chrysler, such as jump timing belts and things like that can affect this. What?
Jump timing belt.
Jump timing belt. Yeah, this was one I had in the past where I had a jump timing belt and it threw me off. And I almost put an engine computer in it. It was early on. It was on a Dodge Neon that I had some students here at our old school. This is probably 12 or 13 years ago. That the vehicle didn't have spark during cranking, and when you let off the key after cranking it for a while, it would throw you one spark. It was weird the way it reacted. So I start checking things, and I didn't have any fault codes that I remember, and I started checking. I checked the cam and I checked the crank individually with a little single channel scope, and they were good. And I guess I really wasn't familiar with these data parameters yet, but what I noticed is these guys were changing yes and no, and I didn't know if that was normal or not at the time, right? I did see the yes, no while I was cranking, and that's what I think led me away from the engine computer and made the students pull the covers back off, just because they said the car ran before and they did a timing belt or head gasket or something like that. And I said, I'm not calling an engine computer on this without inspecting these marks. And here the cam was off by 2 teeth. And that's all it was. And so again, I'm thinking about these things as a guide as I'm working on this car. What you'll find too, this may be a note to you, Cliff, because we were talking about this morning, is what you'll find is your past failures or your past painful moments will carry with you through this field, and years later you'll still be using them. So I'm really thinking about this kind of stuff from the past and cars I've worked on as far as direction, and I looked at all of my different data lists. I'm looking for a guide cam and crank data PID, and they're just not there. So what do we do now? What's the next step? What do you guys think? We haven't seen it yet. You don't know. Where are we going next?
To the crank?
Yeah, I'm going right to the crank sensor. And now comes yesterday's theory, which is what kind of crank sensor is it? How many wires does it have? How do I test it? What are my variables? Right? So yesterday's topic was variable reluctance sensor. It just so happens that's what this car is. It's a 2-wire sensor. It has a floating ground So connecting to it is important that I understand where my scope leads get connected. Let's see if you guys remember. Where does my scope, if I want to see full amplitude,
Positive and negative of the sensor.
positive and negative of the sensor. I don't want to use battery ground, I want to use the sensor. Can you guys understand in this application how important full amplitude would be? In other words, I want to see the signal as the computer sees it. It's critical. So that's where we're going. Watch.
I have no trouble codes, I have no RPM signal. Next thing I need to do, given this being a Ford and the check engine light not turning off during cranking and not having spark, I'm going after the crank sensor next. So we did some digging, we looked in the typical locations around the harmonic balancer in the front, couldn't find the crank sensor. We ended up having to pull a diagram to find it, and it is buried below. It's like behind the catalytic converter, and it runs down this harness. Maybe I do need a light. So the sensor is down in this location, right where my index finger is pointing, and it looks like it reads off of the flywheel on this design. And we were hoping to, you know, the fan shroud was in the way. We were hoping to, you take that light out of there, Jimmy. So we were hoping to gain access to the wiring here, and I just split the protective cover over top, and what I found is a big thick wire here, which suggests there is a shield on this, and I do not want to cut open here. So we did.
What's a shield? Again, yesterday's topic.
Coil wrapped around.
Yes, this is really looks like tinfoil that would be wrapped around the two wires that go down to this sensor. If I would to use a piercing tool into that, that wouldn't be a good idea. You guys understand that, right? And a lot of people are, well, it's more than not being protected anymore. It would be I risk grounding it out. So, yep, I do not want to stick any kind of piercing tool into this harness. Now, I'm limited in where I can test it because of design. The connector's way down here. This goes into the main harness, and the engine computer's inside the cabin. I can't do any easy checks on this crank sensor.
How easy would it be to get it from the bottom?
Well, that's what I'm going to do. I'll show you that. That's really what I was left with doing. But I think it's cool that we just talked about the shield yesterday and how important it is to not disturb them. And then I'll show you that to you on the diagram here in a second.
Didn't have a choice. We had to remove the fan shroud to get down in there so I can test this thing. Let me show you the wiring diagram real quick before we test it.
That's pretty cool, right? I showed you a generic picture in my textbook, right? It was section 21, I forget what page, I think it was like figure 12 or something like that, that I mentioned this shield. And you see that there's 3 wires here, and there's really 2 that go to the sensor. So 2-wire sensor tells me what kind of sensor is this most likely. Is it's most likely a variable reluctance type, number 1. Number 2, the 3rd wire that's up here, you can see is a shield. What does this do? If we follow that terminal, it just grounds the circuit out. It grounds any outside radio frequency interference and pulls it out of that signal. Okay?
Guys, this is exactly what we were just going over in class today. When I say guys, I'm speaking to my current students. You guys that are following along. You will find information where I talk about shielded circuits in my section 21 lectures, but that's exactly what this vehicle has, is a shield, and I do not want to cut into that and damage the shield. I have to go down to the sensor directly. If that was not an option, we were going to have to go to the computer to do it. Unfortunately, that is difficult to get to as well, so we're going at the sensor. We removed the fan shroud to get to it. Something else I find interesting, we have a cam sensor, so why is this not setting a fault code for the crank? I have seen vehicles not set crank sensor codes with bad crank sensors when we don't have a cam. Not sure that I can say that I've ever seen one. No, I'm sure that I have, that I've seen a vehicle not set a crank code even while it's receiving a cam signal. Every car is different in how they react to this. Again, the codes were cleared too. Would this set a crank sensor code if I continue to crank it? I don't know. I'm not going to let that distract me from what I'm trying to do here, which is check this crank sensor.
I think distractions would be a good lesson to pause there for a second. Distractions. Distractions being, in this case, why don't I have a crank sensor fault code if I have a crank sensor fault? Can you guys see where that could make you maybe second guess your direction and go in another direction? And I think this is really, I don't have a good lesson here. It would be experience that is going to say, no, stay on this path, you're on the right path. Don't let that variable throw you off. That's what I'm trying to explain to you. I have seen many, many vehicles with a crank. That's pretty blurry. Let me back that up for a second.
Code, if I continue.
I have seen many vehicles with a crankshaft position sensor fault that, let's say the early systems didn't have cam sensors. A lot of them are early fuel injection systems. And so we only have a crank signal. And if the crank sensor is messed up, you're cranking the engine over. The computer doesn't even know that you're cranking the engine over. So of course you're not going to have a trouble code. This was common to have a bad pickup in a distributor, also known as a crank sensor, or the crank sensor itself on the block on a waste spark system or whatever, that we wouldn't have fault codes for them. Crank, no start, no spark, ends up being a crank sensor, no fault codes. Can you guys understand how that would be? There's no other input for the computer to look at to know that we're cranking. In this case though, we have a cam sensor. So the cam sensor signal is there. You would think this computer is smart enough, I would think, if my cam sensor signal is being fed into the PCM and the PCM sees it, but there is a missing crank sensor signal, fault code, agree? And most of these systems that are out there, that's what we would have. We would have a fault code for the crank sensor. Was there a fault code for this crank sensor?
Could be.
There could have been. Someone was in here, wiped out the memory. So that sucks, right? But I'm not going to let this distract me from where I'm going. Does that make sense? We don't have to worry about, well, why isn't the computer setting a crank code? So now someone might say, well, maybe it's a bad computer, or no. Just go with what you're doing. Don't rely on the fault code, and let's check the sensor itself. Let's see if it's there.
Will that P1000 code go away once other codes start showing?
Yes, good question. The P1000 code, guys, will go away as soon as all of the monitors are run on the OBD systems on Fords. So if you don't have a P1000 code in memory on a Ford, all of your monitors are run. So it's kind of a pretty cool method Ford uses. Okay, good question.
Continue to crank it. Kind of testing is unplugging the sensor. Unplugging the sensor.
Hang on, let me back up.
Any diagnostic tech. From what I'm trying to do here, which is check this crank sensor. All right, a concern for any diagnostic tech in doing this kind of testing is unplugging the sensor. Unplugging the sensor could actually cause this thing to start working and make diagnosis a lot more difficult, because then you'd be unsure of direction. Now, unplugging it, plugging it back in, the car starts, chances are it needs a crank sensor, but what I tend to like to do is not to disturb a connector and try to back probe it whenever possible. The problem is where this thing is located. I'm showing you the two wires. I cut the tape way down below. The shield is up higher, so the lower part of the sensor is not shielded. I can't really back probe this very well because there's a pipe right here. It's a coolant pipe, I think, and it's kind of in my way. I may actually have to unplug this first and then get some back probing tools in there and plug it back in. I'm not sure. Okay, so back probing was not an option, so I'm using two piercing tools that I am not
You should, wait, hold on, let me back that up.
apologizing for.
I just said I'm not apologizing for that. How much crap do you think I get for doing stuff like this?
A lot.
A lot. There's people that are so opposed to poking a hole in a wire that are in this field, and I like one of my subscribers commented before, and I like the quote, and I've kind of stolen it, is there's two types of people out there. There's people that poke holes in wires, and there's the people that lie about it. At least in the aftermarket, we work on 40 different I work on 40 different car lines. There's more than that, 60, 70, 80 different car lines. And so people are always like, why don't you plug in a adapter in there and instead of, you know, hurting the harness like that? Well, I don't have an adapter for 40 different car lines for 40 different style of crank sensors, not to mention every manufacturer, as the years change, the connectors change too. So I agree that ideally, if my sensor is, you know, down in this location, you can't see it, and then the connector, it would be ideal for me to plug in a connector like this that has, actually I'm drawing that wrong, hold on, give you an idea they make these. You would have an extension connector that the wires would go in, but they also have leads that come off here, and then you'd take your factory connector and you'd plug it into here. So can you see that you wouldn't be disturbing the circuit at all? It's basically a jumper that your scope then would be connected here. They make them. Problem is, you'd need to have one to fit this. That'd be the only way that I could do this that would be non-intrusive. So someone else would say, well, why don't you go at the computer and test it? Where's the computer at? All I know is the main harness goes into the dash, and I'm not pulling the dash apart. Because what if the crank sensor has a good signal? Do we need to move away from this crank sensor quickly, or do we have a crank sensor problem? That's where we are right now. You're working in the field, you want to make some money working in this field, you need an answer right now. So what are my options?
Test it really long. Test it there.
I use the hook tool. You guys have seen me use these before. It's a hook tool that has a little pin in it, and you wind the thing up, and I poked a hole in the wire.
Honestly, if anybody's that worried about it, just put some electrical tape over.
Electrical tape won't seal the moisture. Moisture is a concern.
Okay.
When we're poking holes in wires, and I'm not saying that this is ideal, but do you understand in this circumstance that what are my options here? I need a crank sensor signal on this thing, and I need to make sure that I'm making good contact. All the stuff that we have to worry about when we're doing testing is important to me here. I need, number one, to know I have a good contact. I'm confident in these test leads that I do. And then number two is, I don't remember what my number two was. I have nowhere else to measure this. This is it. I could back probe it, but I can't even get my finger down there to unplug the connector, to pull it out, to put pins in, then bend the pins and plug it back in. Did you see how close that pipe was too? And what are the chances my back probing tools move in the process, and then I get my scope waveform, and then I see a flat line, no signal? Aren't I going to question my pins? And how long am I working on that one step alone? Maybe 10 minutes. It's not acceptable. I need to know for sure this is how it's being done. What do we do when we're done with this after we poke holes in a couple wires? I've heard people use RTV, and then I've heard other people say that the silicone in some RTVs is corrosive to copper, so that's something to think about. I'm not sure. The other one that I've been using, I talk about it, I even mention it. Yeah, it's actually, you can't see the label on it anymore. I bought that from Walmart. It was $5. Liquid electrical tape, so it's a gooey stuff. Yeah, and it actually seals up pretty quick, dries pretty quick. It's like a rubber type texture when it dries.
Almost like bead seal?
Yes, bead sealer for a tire or for a rim would be almost exactly the texture of that. Okay. So yeah, it was cheap. It was $5, and when I'm done, that's what's getting put on this. Does that make sense? Yeah. Sometimes you have to. And people that say you should never back probe or pierce a wire, yeah, I don't know. How long are you going to be working on this car if you don't have the adapter, which we're in the aftermarket, that's what we do. If we don't have the adapter and we can't get to the connector, what do you do? I need an answer.
You have to get to the connector for the adapter anyway.
Exactly. You know, and I said in the video, I'm not apologizing for this, and that's kind of what I'm doing right now, isn't it? I'm kind of apologizing for poking holes in wires.
Not explaining. Poke some more holes.
No, I'm more defending myself from the people that'll be like, you shouldn't poke holes in wires. And I'm like, there's, as I said, there's people that poke holes and then people that lie about it. I really believe those are the two classifications in this field. Is there times we have to worry about doing testing like this? Of course, as technology changes, you guys need to understand that I'm working on a 12-volt system here. There's no dangers of electrocution. on hybrid systems and anything more than 40 volts, we have to worry about stuff like that. I'm not doing this kind of testing on my home wiring.
Don't pierce the orange wire.
Yeah. Airbag wires, we wouldn't want to do that, right? So there's certain things we don't want to do, but I'm okay with this. Put some liquid electrical tape on it when you're done. Be happy about your quick test, and that's what I'm doing.
Say that when you're finished doing something like this, put a little bit of liquid electrical tape on the holes that you made and be good to go. No choice here. Let's see what the signal looks like. Set up on a 14 volt, 5 millisecond screen. That's too fast. Let me just reset this. Milliseconds. Pretty decent beginning setup. 100 millisecond screen, plus or minus 5 volt. Go ahead.
Before you guys see the waveform here, stuff I'm thinking about is what type of signal am I going to have? It's going to be an AC sine wave, right? 2-wire sensor. Number 2 is I'm cranking it, so I know that my amplitude's going to be low. That's why I narrowed my voltage scales down, right? And then number 3, during a crank, I don't care about detail. What do I want to see? I want to see repetition. I want to see what this crank signal looks like, which is why I took more time. When I first set the scope up, or waveform viewer they call it on this older unit, it was on 5 millisecond screen, and I raised it to 100 milliseconds, and you'll see as I go, I raise it even further. I want to see repetition here. So these are things for you new scope users out there, and that's you guys, that when we're acquiring a signal like this during cranking, I want to see repetition.
Let's just bias voltage.
Does this have a bias? No, this one doesn't use a bias like we talked about yesterday, and that would be, what, my section 21. It's probably, for you, Michael, you missed yesterday, so where is the discussion of bias voltage? It would be probably in part 1 or part 2 of section 21 is where you'll find that conversation. And that would be on my premium channel, the lectures I'm talking about. Of course, in the book too. But this one, Matt, is a floating ground design, Ford. Okay? So the floating ground design means I have a signal on the positive wire and on the negative wire, and no bias, no DC bias, but a floating type ground is what this one has. Okay? And that's why I went both leads to the wires themselves. Instead of one to the positive and one to battery negative, my both scope leads went sensor positive, sensor negative.
Crank that, Jimmy. Okay. Sounds like our starter's going bad and our battery's weak. You hear that little click initially? The little... All right, no signal on the crank. Show you what the cam looks like. Ford likes to use floating grounds, so you guys that are
just
following along will understand why I'm back.
Let that go for a second. I'll just let that play. You see, again, I'm back probing both, knowing it's a Ford floating ground type system. Pause that for a second. That's what I wanted to do with the crank sensor, but I couldn't. Right, back probe it like that. I really don't have to show you the cam signal. I mean, we could have stayed focused with the crank, but I'm doing this for a few reasons. I want to make sure that the cam signal is there, and then I want you guys to see what a good sine wave looks like. What I'm looking for really on the crank is what we're about to see on the cam. So let's get our volume back.
With floating grounds. This should be my cam signal now. Go ahead and crank it. Okay. Saw our pulse there. Let me readjust these scales. We'll take some more time, and we will lower these. Amplitude and frequency changes with speed. Go ahead, crank it. Okay. See a good cam pulse.
So we have a cam signal and no crank. Definitely needs a crank sensor. See my time base, I changed it to 1 second to get more. I wanted to see repetition. As far as what the signal actually looks like and the format of it, I'm not worried about, just that the signal's there. Does that make sense? We've talked about some pretty in-depth views of some of these signals. You remember the Chrysler one I gave you that had, each window meant, 69, 49, 29, 9 degrees before top dead. That's the kind of information we need in a classroom setting, but not on the car. When we're troubleshooting, you do not need that kind of detail. I just want to know if the signal's there. Is my cam signal there? Is it there? Yes. Is my crank signal there? No. All right, so it looks like we have a faulty crank sensor. Very nice and easy, right? There's a few other things I'm going to show to confirm it, but let's just back up for a second. No start, no spark. Crank the engine over, check engine light did not turn off. That said what? Possibly we're missing a crank signal. RPM never changed. Again, crank signal. No scan data PIDs to help me, no codes. Go under the hood, check my crank sensor, no signal. Is there anything else we need to think about before we put a crank sensor in this? Obviously with, let's see, about 7 or 8 more minutes left of the video, there's something else. Timing. Not worried about timing in this case because even if my chain was jumped or broken, the crank sensor reads off the flywheel. So I should still have a signal, but...
What about the circuitry?
Hang on. Let me address the timing first. Would a timing issue cause a no start for sure, but would I still have a crank signal in that scenario in this car? And the answer is yes. So a timing issue is not the case here. Could we have a timing issue where we had no spark? Yes. So what would this have looked like if the belt was, say, broken or it was jumped?
You'd have a crank signal.
I'd have a crank signal. I would have a check engine light that would have turned off.
Yeah.
I would have had an RPM signal that would have been bouncing on the scan tool, probably, maybe. I may or may not have had a fault code for that, and some of those would be a cam crank correlation code. But you see the direction would be different. Nick?
That's about the circuitry to the cam.
Yes. Yes. Circuitry to the crank sensor is really the final part of this before we make a call on a faulty crank sensor. What do we have to worry about? What do you think with a flat line 0 on the crank sensor, what do we have to worry about? And this is where the theory comes in. And I said, a lot of what we do, it's difficult in this environment. It's difficult to talk about floating grounds and variable reluctance sensors and frequency and amplitude and, air gaps and all those things we talked about yesterday. But it's pretty easy to apply it once you're in the field. Well, here's my sensor setup. I have sensor here. I have wiring that goes to my computer, and that's pretty much it. That is my setup. I am measuring where? Right at the sensor with my scope. Okay? And I have flat line 0. Am I worried that maybe my scope isn't connected properly in this case? I'm not. That's why I used my hook tools. I absolutely made sure my scope works, and really part of that was showing you the cam sensor signal too, which gives us a little bit of confidence that, hey, our scope is working, the cam sensor's working, I'm doing this right. So I'm not worried about my scope connections. I'm also thinking about the floating ground. It's a Ford. So I know that with a floating ground system on my crank positive wire, there is a sine wave, and on my crank negative wire, there is a sine wave. It's in the opposite polarity. And the reason that I went together with my scope is difference in potential. What would do with the amplitude? If one is going up and the other is going down, when I compare the two, it makes the signal multiplied. So when you're looking and dealing with floating grounds and I'm worried about a crank signal and making sure that it's actually there, that's why I'm connected this way. This is all that theory I'm thinking about from yesterday. So that's where I'm at, and I have flatline 0 volts. What would be our possibilities here? It can't be, and I addressed this, it can't be the flywheel, right? Because the starter cranks, it's engaging the flywheel, the engine turns. So what I'm getting at is, couldn't we have movement, a movement problem? You guys that did the caddy for me, think about the timing chain being broken. Would the distributor ever turn? And if the distributor never turns, then would you have a signal from the distributor, from the crank sensor, which would be the pickup coil, and the distributor? The answer is no. So do we have to, at times, think about rotation and movement? For sure. In this case, do we? No. So if we have, is there movement? Question mark. Not a concern here. What else? Is it the sensor opens and shorts? Are we worried about a bad computer? I'm not, and I would
Keep it in mind, but let's go.
keep it in mind. Okay, I agree, but now it's important to apply the concepts of a variable reluctance sensor, which is what? It's a 2-wire sensor that what? Produces its own voltage. How important is that piece of information right now? It's crucial. If this was a sensor that modified a signal voltage from the computer, would we be worried about the computer? Would the computer be in the list? Yes, and that'd be Hall effects and opticals, and we'll get to those. But in this case, just knowing that sensor produces its own voltage, knowing that if I cut these 2 wires right here and just completely eliminated them and hooked up my scope like that, what would I see? If I cranked it over on a good system,
You'd see voltage.
I would see my sine wave. It would be there. How important is that perspective right now? So my PCM, the PCM being an issue, that's never really, shouldn't even be on your list.
You don't have to worry about shorts or opens.
I do have to worry about shorts, but I don't have to worry about opens. Because as I just said, if I cut the wires here, what am I going to have? I'll still have a signal. How would that play out if the wires were broken? Maybe if it was just one wire that was broken, or both, doesn't matter, would I still have a signal connected like this down here? I absolutely would, okay? So let's say that, for example, we had broken wires. The approach so far would be the same. We don't have spark, because the computer's never seeing the signal, agree? So we don't have spark, we crank it over, check engine light never shuts off, tachometer never bounces, may or may not have a crank code. What's different? Where's the change up? When we come down to the sensor and measure it, what do we see? I see a signal. Doesn't that contradict our direction and where we thought we were going? Same exact step so far. Says crank sensor's direction. Check engine light doesn't shut off, tach doesn't bounce, no spark. Sounds like a crank sensor. It's a Ford. Go down to the crank sensor, measure it. What do we see? Good signal. Now what would you do if that was the scenario? What would you do now? I would start focusing on the PCM's control of my, not easy to see red over red. I would start focusing on the control of my coil. And there's 2 wires that are the control there. Do you understand how I'd shift directions? I'd move probably away from this, and then I'd come over toward control for the coils. And we haven't done that yet. We will be. This will be section 22 material, where we look at coil control. And then what I would have found is there's no control here. And then I would have started focusing back at the computer. Think of the Dodge truck. This is very similar in direction. What did I make you guys do before we called a bad computer on that Dodge truck?
Bidirectionally pull the main spark.
Okay, good. Bidirectionally see if you can fire these coils, but I can't do that on a Ford, so that option's not there for me. But if it was, if I could connect a scan tool to this and command the coil to fire, and it doesn't that put me back toward an input problem, if that's the case? And if it doesn't that put me toward a computer issue, output side? Yeah, so I can't do that though. What else did I make you guys do, Dodge truck? Bidirectional controls, can't do it on this Ford.
Probe it at the computer.
Very good. Probe it at the computer. Okay, I have a signal here. I understand the sensor produces its own voltage, right? Don't we have to make sure it's getting there? So your next steps before ever condemning this computer would be to take the same measurement at the computer, and what you would find in this scenario is what? It wouldn't be there. And now we know we have an open in this circuit. It's good down here, right? But it is not up here. We have an open circuit, go find it. That would be what this would look like. So opens is not here, right? Why is an open not a concern? I would still see a signal down here. So what are we left with? Shorts or the sensor itself? Does that make sense on where we are? Shorts to ground or the sensor itself?
Shorts get rolled out anyhow.
No. Because wouldn't it, if the wire was touching ground, would it pull the whole signal that was being produced to ground? It would. And I don't want to go to the computer and ohm the circuit. That's not what I'm going to do. So we didn't talk about bypass testing yesterday. That's what I'm going to do for the rest of this.
What we want to do, final check, well, we can try it, I don't know if it will work, is a bypass test on the crank sensor. Okay, move my leads back on the crank. The crank should have a much higher frequency signal, but I'll stay on the same time base and setups that we saw the cam signal on. Go ahead and crank that again. Okay, good. All right, so we have no crank signal at all. The last step really would be opens and shorts in the wiring, but this sensor produces its own voltage, and even with opens I should have a signal. So it's really shorts that we're worried about. All right, we're going to try this bypass test. What I've done is I have left the connections to the crank sensor, and so we have crank positive and negative wires here, and I don't know which one's which, it doesn't matter. Fords use that floating ground, so I have to really induce a signal on both, and for me to be able to do that, I'm just try this. I'm going to use my piercing tools, and then I'm taking my test light connected to battery positive. I'm going to touch a ground, it should light. Okay? And so I want to induce a voltage in here, and I'm just going to go back and forth. You see my light's not lighting on either one of these, so that's a...
If that test light lit on this particular design sensor that uses a floating ground, I'd have a short to ground. My test light doesn't light on either wire. How's my wiring? What's the problem? Sensor. This bypass test doesn't work. I can't make it react. So this is really the end part. I don't need to show you the rest of it. You can watch it on your own if you want to. This is on my free channel, and if you want to see this part, this will not be on the free channel. But this is a bad sensor. But why would I want to do this test? It's listed in my book as a bypass test.
You're a parts changer.
I'm not a parts changer, that's one. But wouldn't this, sorry, go ahead.
Checking for shorts.
Checking for shorts, that's the other one. What's the maybe main reason I like to do a bypass test?
Confirmation.
Confirmation. Absolutely. If I can make this computer fire this coil, after we've done all of our checks, how confident are we that this needs a crank sensor? 110%, if that was possible. Does that make sense? Fords, floating grounds, can't make the signal. I don't know if it's because of the floating ground or it's, I mentioned in here in a minute that it's a 36-1 trigger. And what that means is the crank sensor reluctor on Fords, I believe this is the design, it has a flex plate or part of the, normally it's a harmonic balancer, so maybe this one's different. Anyway, what we would have is, we would have 35 evenly spaced teeth all the way around this thing, and then what there would be is a missing tooth, and that's why Ford calls this a 36-1 trigger. What is the missing tooth do? Why does it need to be there? My setup for my ignition is I have two coils. There's coil 1 and coil 2 that are both computer controlled. And I need to know, I'm the computer, I need to know which coil to fire first. Remember, this is waste spark, so it's pairs. And what the missing notch tells me is which pair of cylinders is coming up to top dead center. That missing notch is what tells me where to start sequencing the coils. So is it just possible that given this design on a Ford, it really isn't the floating ground as to why I can't trigger it? It's more that I just can't duplicate this signal. Because it's pretty exact and precise that the computer's looking for, and I certainly can't do it with my test light. I'm just trying to drive the signal high and low. It's not really going to be a true sine wave either. So, you know, I don't know. Can't make the signal on a Ford. Questions on that? All right, so I have a suggestion for you guys to learn a little bit more about the bypass testing. And that is, I'm gonna show you how to do this. All right, so from my channel page, what I would want you guys to do is to go on the search channel. You could also do it on the video page too, and then type in bypass test. Keeping in mind that what I've done with all of my videos is put keywords in, and this should give me a list of videos where I've done a bypass test. And VRS bypass testing, isn't that what we're talking about? How to test an ignition coil with a test light. So I'm creating spark in this one. Bottom one is a camshaft position. Another one is computer controlled door locks, a digital speed sensor, an alternator. All of these videos, I've done some type of bypass test. I was with my son. This one was fun. I was with my son and we were working on a Saturn that had a bad crank sensor. And actually that one might be a good, I'll just show you that piece.
So I got my son Beau with me here today.
Yeah, Beau was helping me troubleshoot. This one was cool. And I'll just go later into this for a second.
So
my fingers are on the crank sensor wiring. The crank sensor wiring is above the starter. Really difficult to get to, just like the last one. And I did all my checks just like I was showing you guys. I think I did this a little different. I can't remember exactly. Really, what I want to show you guys is the bypass test. Same kind of scenario.
Oh, I'm going to do that. What it's going to be is test light to battery positive, and then I'm going to touch on and off. I believe it's the yellow wire that's the positive. I'm going to try it on this one to the right, and then I'll do it on the one to the left. All right, there's no way I'm going to get this camera shot in here, so I'm just going to do the test. You guys are going to watch me do it. What I'm listening.
All right, so why am I doing the bypass test again? What's the purpose? Confirmation. I already know that this thing needs a crank sensor. I have no signal in this thing, and I want to see if I can make the computer react to it.
I'm listening for the injectors to fire, and I'm listening for the fuel pump to turn on. So it's going to be a sound thing here. I'm going to be quiet here. I have light in my mouth, so
That's why.
using the hook tool here.
No, I'm piercing the wire.
First.
No, he doesn't even know it's going to pierce.
Just gotta make sure that piercing the wire. Take my test light to my tool here. Make sure the light works. There we go.
Listen.
First try. That was awesome.
Did you hear that? That click was the injectors fired. I gave the computer an RPM signal. Computer turned the fuel pump on. And then I show this again later that I can actually make the coils fire doing this. How does that make you feel about crank sensor now?
Pretty good.
Ford that we just did, does it matter that the bypass test didn't work?
No.
I mentioned this in my textbook too, that the bypass test sometimes doesn't work, and that was a good example of when it doesn't. Don't let it mislead you. Sometimes you can't create the signal the computer wants to see. Bad stuff on this one, by the way. My son, and you have to watch this when you get a chance. We were at Latour's Auto, and he has a wood stove in his shop, old school, and I'm next to the wood stove. It's wintertime. The customer had pulled his fuel filter off, the line off the fuel filter to see if he had fuel before he brought us the car. And he didn't because there was no crank signal. Well, what did I just create? A crank signal. What did the computer do? Turn the pump on.
What was not on it?
The fuel line wasn't on it, and Beau yells at me. He's like, "Dad, there's something leaking back here." I'm like, it's just the snow melting. I like totally disregarded what he was saying. It wasn't just the snow melting. No, but it was close. I mean, I was right next to that wood stove, you know? Maybe having a wood stove in a shop is not a good thing, but it's off the ground. Fortunately, it's way off the ground. So the fuel vapors were low. Could have been bad, you know? Could have been bad. My son was with me. Could have been real bad. Let me just jump ahead. I want you to see the spark with this test because I do show it. I know I show it.
On that crank sensor wire, we'll go ahead and get in there and on and off on that. Yep. All right, now hold on. Do that again. Don't worry about the sound.
All right, so I'm looking at waveforms there. I got Beau triggering it for me. I want you to see the spark.
Cute me.
He's laughing because I told him don't do it yet because you'll electrocute me. So that was fun for him.
Just show you guys we have a spark. This.
Can I do it now?
Yeah, I could do that. All right, we're gonna switch ends because this is a different type of spark tester. Here, do that for me, Pete. I got one hand. Does that reach in there? All right, then we gotta go to ground with this.
Can I do it?
And go ahead and do it, Beau. On and off. On and off. Keep doing it. There you go. On and off. A couple more times.
I wanted you to see the spark, but I think it's more the lesson on how to do it. When you're doing a bypass test on a crank sensor, you're really not producing the same signal the computer is. And the reason you're doing it over and over is you're hoping that you make a signal that would be, one of the coils at one point in time, the other coil at another point, and so that's why we're doing it over and over. But you heard the reaction. I think I show the spark, but that's good enough. This is a goofy spark tester that Pete had, but bypass testing. When you guys come back from break, we're going to talk, well, really, I covered the bypass test with you. I'll show you where this is in the text, and then we'll probably move on to Hall effects next. Cool? All right, go take a break.